Welcome to the lecture series on object oriented analysis and design. So, what we have done is to begin work with all these concepts, we should first have an idea of what is that language that will allow us to be happy with the kind of object oriented concepts which we have in mind, which are now related only to the problem. That was the first advantage of object oriented analysis and design. The problem speaks objects, the task at hand speaks objects, and we have done all this exercise to make sure that we are very quick to identify those objects: tangible, intangible, abstract, virtual pointers, virtual functions, whatever we are talking about. All that is primarily to improve the people productivity. And when will the people productivity become pronounced? When everything is targeted to the problem. It is a paradigm that taught us a way of thinking so that we won't miss the context, we won't miss the domain, we won't miss the stakeholder, but we will still be able to generalize. In the earlier work, first 2 decades, we have been missing out the context, we have been missing out the domain, we have been missing out the stakeholder, nothing specific, everything abstract. Straight away jumping to the abstraction made us completely disconnected with the problem, the context, everything, get more and more oriented towards the machine, the zeros and ones, to be precise. That was a problem we had. Not that it had something else to do, but then we have completely lost connection with the problem, people, context, stakeholder, whatever you want to call. This paradigm is promising because it always keeps us in touch with the context, the people, the way we talk about resources, the way we model, the domain, the multiple stakeholder, and the machine and the developers, the process, everything together. We will not lose out on anything, but then that is a special way of thinking. We called it object oriented. How much of this can really go into the machine, towards the machine, is a question. That is when we are working with OO. Well, if you want, you and I can sit down and generate one language tomorrow. Call it OO Anna. You can call it. You can create a grammar. You can go ahead and then make sure that it is nicely compiled. Lex is there, syntax analyzer, and then yet another compiler is there. If you can write up those simple concepts which you must see, and then what we need to do is to come up with a context free grammar, a Lex, a Yak, very quick time you have a compiler, you can start working with that language. So, what I did very early was to take this huge language called Ada and then tailor it down. This is also possible. There is an existing language, there is a tailored down Ada. Let us say it is called lightweight Ada. You can give it a nice name, lightweight Ada. Most of the things are the same, but it is tailor made specifically for a given purpose. What was the goal for me at that time? We had a very rudimentary machine, and it refuses to take the full Ada. So, you take the language Ada, trim it down, so that it becomes a very lightweight Ada. So, for every language that is seen on this particular table, Effect, Smalltalk, Ruby, we can always talk about variants, we can always derive other languages, we can make more languages, you can create your own language. And as I said, today we have wonderful tools like Lex and Yak with a nice interface, nice developing environment, that writing up a compiler optimized or intelligent for the language of your design and your choice is just that easier. However, is it in adherence to the standards? That is a question mark. For that, you will have to go through a rigmarole, and please remember, we can interoperate only if we are in adherence to the standards. We can make something very specific, but as long as it is here, it is all right, but if it has to talk to somebody else, it is not simply possible. So, interoperability is the key, and we start moving forward. We look at these functions for our given problem. We have used this many ideas, this many concepts. Please check that which is pointer arithmetic. It is not there in effect, not there in Smalltalk, not there in Ruby, not there in Java, not there in Python. Then where else can we use this? Without pointers it is becoming very difficult. Arithmetic done to a large data set, it is necessary, pointer is necessary. So, once you start telling I have a feature called pointer arithmetic used, you can either choose C# or C++. Now, what else is the differential? We have a bigger question. Do we want to have multiplexing inheritance? Only C++ supports. If you want to have it, you go ahead with C++. We have chosen a language. A rough table which indicates that the language features are necessary to be studied and mapped onto what are the concepts that enable us to do the problem solving like we have contemplated and improve the people productivity also. There is no fixed rule or principle based on which a particular language can be chosen for developing software. The decision of choice of language entirely depends on the characteristics and basic needs of the application to be developed, reusability of the existing code, the impact of organization on the choice of programming language, and various other aspects. In theory, we have always been propagating the idea saying that let us not choose a language because you know this language. You have to study the problem, find out what are the strengths of the language, what are the strengths of the problem, and synergize in a manner where you leverage on the strengths. That is the practice. So, we have to work in that manner. C++ is the most successful and widely used general purpose object oriented language. In my earlier lectures, I have also noticed that all the syllabi will have C++, they have C++ in tandem with object oriented analysis and design. Most of the code segments are based on C++. It can be in any other language. There is no reason to believe that C++ is the only language. It is the most successful language because all top rated features, all top rated object oriented concepts are found in C++. So, we found that C++ is very nice. In OOP, writing programs with the help of objects is much similar to working with real world objects. That is, the real world objects can be conveniently represented in a program, which reduces the complexity of the program and also makes the program structure clear. In object oriented programs, each object is an independent and separate entity which makes modifications everything is localizable. If at all anything goes for a toss, it is the object. It is not the big picture that is going to be impacted. So, the bottom up approach, localization of defects, clearing up of the defect, these are all very good ideas, easy to write, easy to maintain. In object oriented programming, data integrity and data security is high because there is encapsulation. How can anything be known when nothing in it is telling what is inside? Data integrity, data security is absolutely fine by different parts of the program. As a result, object oriented programs are less error prone, more reliable and secure. Object oriented programs are easy to extend as new features in a program can be added easily by introducing a few new objects without modifying the existing ones. We can add, we can remove, we can create some temporary functions, we can create friend functions. Object oriented programming allows reusability of the code. Well, the rate of success is what we are talking about. Object oriented programs are easier to adapt and scale, that is, large systems can be created by assembling reusable systems. What are the applications? Simulations and modeling. In these areas, object oriented has shown remarkable success compared to any other paradigm. Since 1960, simulations and modeling. Simulation is a technique of representing the real world entities with the help of computer program. The language called Simula 67 and Smalltalk are two object oriented languages are designed for making simulations. Simula 67 appeared in 1960s, one of the very early languages. It was a wonderful language and all simulations and modeling are very easy. Now, to do the same thing much later, we had two packages specific purpose simulation software, general purpose simulation software, SPSS, GPSS. Wherever we were going as young computer scientists, the simple question was, simulation is better done by SPSS, GPSS. People were not so much keen on simulation. They did not want to have an inventory of a language. Simulation is just some sort of an initial idea as to what you are thinking. Simulations were not considered strong methods or proofs. So, that way of modeling was not finding a very good success, but please remember that the early languages Simula 67 and Smalltalk had a good success rate of at least telling that very quickly the simulation is efficient, effectively done, and it reflects the real world. Much later we thought that maybe if we go back to the programming language, we can do the simulation of our choice rather than buy the big package. Even SPSS is a big package, GPSS is a big package. Why do we want to learn so many things? Had we gone back to those days of Simula and Smalltalk, we would have tailored our simulation, but well, with hindsight everything is like that. User interface design, that is the first thing we have been talking about. The entire interface talks to the user based on the task. This is how it is to be done. You want to do this, the user interface speaks for itself. The vending machine, the ATM machine, the fan, the light, they talk very readily amenable. Developing computer games, this is still an ongoing exercise. Well, we found some excellent high complexity computer games like Diablo, StarCraft, Warcraft, very nice, reasonable complexity where people with a higher degree of commitment can go. Scripting, in the recent years OOP has always been used for developing HTML, XHTML, XML documents for the internet. Python, Ruby and Java are scripting languages. Now, the scripting language is very much banking on the browser and very quickly it goes to the back end. It does not draw so much on the front end. The idea of front ending, back ending, everything is nice. Scripting simply tells me that the browser will carry forward everything into the back end, where best of the things are there, more complex things are there. The user machine is a sleek, simple machine. It just runs the browser. The browser will take care of the script. Any machine, any device that can launch your browser is enough. Now, what we are doing is that we have been challenging this method. Edge computing is what we are talking about. Most of the things should be done on hand here. We have had several reasons. Technology has progressed like that. Scripting was a runaway success because the fellow who wants to get things done, all that is necessary is to run the browser. We have had arguments, we have had debates on the browser, how to choose a browser, different browsers are different, browser settings, so many things. We have had lot of difficulties. You see, for so many years in our system, we never allowed anything called a plugin or something called what we call the browser would want to have certain things installed on runtime. We won't allow it. Then you can't do anything with that. That application warrants that certain things be permitted. The runtime of whatever you want, whatever is being contemplated warrants that. You will have to allow certain plugins. You will have to allow certain cookies now. Cookies are state information. If the setting does not allow, you can't do anything with that. So, gradually we understood that there is a need to make sure that the front end, back end, scripting all get into a perspective where the overall application development, the bigger exercise of application development is kept in mind, and OOP is therefore helping us. The scripting languages are there, but an object oriented approach will give the bigger picture more easily and try to fit in whatever it is happening. Object databases, these days OOP concepts have also been introduced in database concept. OODBMS is quite popular. It began in a very simple manner of looking at the table of a typical RDBMS and then asking ourselves a query, what happens if there is a very big video clipping to be included in the table. One of the attributes in the table is a video clipping. So, in the world of RDBMS, ages back DBase 3 plus, the old world DBase 3, Foxbase, Fox Pro, all these things were giving us a nice idea called blob, binary large object. So, we started seeing the need for creating some objects like videos. Today everything, YouTube's, whatever is happening is based on object databases, because they are large databases, they are large objects. The idea of binary large object or binary large object coming in as a pointer in your table is now more expanded. It is an object database, all objects are there, everything is an object, very quickly you can access. Every object will have a unique identifier, because it is how we make identity is a very very important parameter of an object, and once you give the unique identifier it goes. Document identifiers, document object identifiers, you have published a paper on the net, it has a DOI, you do not have to remember anything, just tell the DOI, I will get the document wherever it is. It has a unique identification, that is an object, class of papers published in a journal or whatever be the attributes. OODBMS is now becoming very very important and very very pragmatic. There are some good results outside of these handful of very dominant applications, successful application areas for OOP. It has been found successful in office automation systems, decision support systems, artificial intelligence and expert systems, neural networks, parallel programming, computer aided design systems. So, we have had other important areas also benefiting. However, as mentioned earlier on, managing complexity using programming paradigms, multiple programming paradigms is what we have learnt. We are yet to find a paradigm that will take care of everything that we want to do. Case in point, artificial intelligence, functional programming, logic programming. They are very good for artificial intelligence and expert systems. We will not do OOP in this area when there is a possibility of doing functional and logic programming. Logic programming here, functional programming here, you can simply split that. So, it is definitely possible to do that. For parallel programming, a separate paradigm is there, parallel programming paradigm. For computer aided design, we may want to do something else, we may have object oriented is good, but then we want to have a simulator associated with that, something more like a language that supports Simula. So, we have been talking about some good results. If you want to, you can develop, it may be better, but then there are other paradigms that are tailor made for these domains, and that is how we talk about it. So, what we therefore did was that a quick look at what we say when we want to know the object oriented and work with object oriented. This is how we started, but then how many of us need to know so much about object oriented programming and still feel correct? Are there some standards? Is there a way in which we have a clear cut answer saying that is this object identification as per some given standard? Is it possible for us to do that? These are certain difficult questions, and we do not have a ready made and a complete answer for that. So, what we have done is very simple. We said that using the object oriented paradigm, within the total available time, 50% was being used for analysis and design in the traditional approach. Now, we can increase it to 75% or let us say 70%. The coding phase is not necessarily to be so dominant, because once the OOAD is done, coding is just a matter of fact. You have to choose a language, press a button, it will come. The testing phase is still that robust. Whatever we have been doing earlier as testing, we are still doing as testing. The object identification and modeling, we do not have that many techniques, just a handful of techniques: textual analysis, tangible entities in the application domain, behavioral analysis, scenario analysis, database approach. These are the 5 approaches, each has a limited scope, each takes us up to some point, but then in the overall big picture, are we doing it right? How do you know now at the time when you have cleared an object that it is correct? Difficult questions, but then we know for sure that this is what is called object oriented software engineering, which we are attempting. The specification is rarely complete and correct, the analysis, object identification, most difficult aspect. We still do the traditional design like optimization, orientation towards computing techniques, but what is very special to this design is modeling, coding a mechanical and minor part. So, this is a significant progress which we have made in using object oriented analysis and design, and if we can tell that in a context where software engineering did not bring along with it very many hard and fast design principles or design rules, this is a significant achievement. We talked about languages. When we start moving around, we know that these are the choice object oriented concepts, and this is how we cast it in a language. However, are there any standards? Is there a way of cross checking for ourselves that are we on the right track whenever we want to? How do you know, how do you anticipate that if these are the objects, how is the end goal, is the overall set of well defined outputs going to happen? If I want to build a bicycle, should I start with a chain, or is there anything else that I can start with? How do we start building a bicycle? With a pedal, with a chain? What is the simplest way? What is the simplest solution? So, we have been talking about such ideas. We said, computer, for example, how do we assemble and disassemble the computer? This used to be a very nice idea. Occasionally when we had a possibility, we used to get the students around, cut open, break open the computer step by step, reassemble. We were finding it very cumbersome. So many screws have to be fitted, so many screws have to be removed. These were part of our regular rigmarole. Students were not allowed to do too much on the hardware, very expensive, replacement was very difficult, but however, it is a part of our exercise. Once we will have to make it happen, cut it open, reassemble, it should be done. Now, it is a very cumbersome exercise. You have to keep track of so many nuts, so many bolts, take out, explain, this is the motherboard, the integrated chip and the motherboard and other board cards were so nice. The add-on cards were wonderful, they have a better objective and a better objectization. It is a bigger exercise. Mother card is this, motherboard is this, add-on card is this, this is the SVGA card. It is easy to show, the components are easy to show. Now, what happened? We started operationalizing it, still it was meaning too many components and too many screws. So, what we found was one brand, Dell, only one screw. Just remove that one screw, automatically the computer stands opened. Again, hardware is a field where there has been significant maturity. So, it was easy for us to understand. Such things are not there. Again, when we talk about tangible objects, we see what we are talking very nicely in our mind. If it is abstract objects, there are neither standards nor there are specifications. You cannot be here, you cannot be there, you cannot be everywhere, that is a kind of a thing. So, what we ended up was try and come up with what are called methods. We created some methods, good, bad, right, wrong. This is how we follow the method. The paradigm is clear. Some aspects of that paradigm called object oriented paradigm will be put together and we call it a method. If you follow this method, these are the things that happen blissfully, these are the things where you are likely to be stretched, you may not succeed at all. So many methods were there, of which general object oriented design, good, was a nice method. Hierarchical object oriented design, HOOD. Object oriented structured design, Jackson's structured design. Booch 91, object oriented design language, OODLE. Class responsibility collaboration, Code Yodan method, Rumba OMT, Object Re. Ivar Jacobson gave Object Oriented Software Engineering, OOSE. Most of these methods were normally considered open. However, some of the methods had their proprietary counterparts. One of the very early methods which was easy for 5 to 6 member team to work with, CRC cards, class, responsibility, collaboration. Simple teams, small exercise, it is nice, it works. That kind of a way of monitoring the work using the card was well known. So, these are only few methods, there are many more methods. Out of so many methods, Buch 91, Rumba OMT and Ivar Jacobson's Object Oriented Software Engineering were dominant. After 5 years of usage, put together we derived what was called Unified Modeling Language. Today, every textbook talks only about Unified Modeling Language. We do not have any other way of talking about object oriented analysis and design. Is established for nearly 2 decades. However, to understand how the UML has happened, the next lecture will be on object oriented methods. Some methods we will study and then we will understand how UML has arrived and why it is so important. 3 methods, Buch 91, Rumba OMT and Jacobson's OOSE have punctuated the entire way in which unified modeling language happened. Thank you.